Hello! Today I will show you how to blend Niagara Flipbooks to achieve smooth blending between frames. So, let's begin. If your particle lifetime is very long or you need slow motion, you might notice that frames start stepping. To fix it, we need to use frame blending. We're gonna talk about two methods, SubUV blending and motion vector. As you can see, SubUV blending adds nice transition, but you can clearly see the ghosting on the edges. Motion vector doesn't have that ghosting, but it requires a texture. That can be done in programs like Houdini or EmberGen, as I did. And if you want to see breakdown of my EmberGen simulation and material graph, please let me that in a comment. First, make sure that you have SubUV animation module in your Niagara system. Match frame range to your flipbook, then in sprite renderer, set sub image size to match your flipbook size and turn on SubUV blending enable. It's important to know that enabling SubUV blending might have slight impact on your performance. Now create new material and add particular SubUV node. Pay attention that this node is not the same as texture sampler. Texture sampler doesn't support frame blending. Now you can plug your flipbook to whatever output you need, but there's one more difference between particle SubUV and texture sampler. You can't manipulate UVs of particle SubUV node. Don't forget to add your material to your particle system. Back in Niagara you can see that the SubUV blending is now working. You can also add cutouts to our system to optimize it by removing empty space. However, keep in mind that the cutout is applied based on current frame. This means sometimes during a blend, the edges might get slightly clipped. Now let's work on motion vectors. For that, we need second node that SubUV provides us, particle SubUV properties, and motion vector texture. Make sure that the texture is using vector displacement compression, sRGB disabled, and you can scale it to really low resolution. To keep things organized, I like to create few named reroutes nodes, such as UV0, that's our current frame, UV1, that's the next frame, blend value, that's the 0 to 1 time between frames, and distort intensity, that we're gonna use to scale our motion vector. Now, let's add two texture samplers with our UV0 and UV1, invert the red channel, and use constant bias scale to remap our values from 0 to 1 to -1 to 1. Then we need to divide our value by flipbook row and columns, and multiply it by blend value. For UV1, we need to invert blend, so add a 1- node before multiply. Multiply both values by distort intensity. And now, we need to offset our values by that value. For UV0, add its value, and for UV1, subtract the value and add the name reroutes nodes at the end. Now we need two texture samplers, one with UV0 and second with UV1. Lerp those values with blend. For distort intensity, we need to use very small number. There's no good formula for that number, so you need to eyeball it. I like to divide 1 by my parameter, so I can work with larger values. Best method for eyeballing is to set flipbook animation based on particle normalized age and set its lifetime to larger number, so you can see the blending. And that's it. Now you can slow down your particles as much as you want, and it should look good.